Welcome to Homework Lib.
Okay, so we are doing a Hoffman elimination, which is essentially where you take a amine, in this case a rather complex amine, with a phenyl ring over here, and then the amine is a tertiary amine, and we react it first with methyl iodide. Then with silver oxide in water with heat. And so what this elimination does is it always gives you the so-called Hoffman product. The Hoffman elimination product. And that's as opposed to the Zaitsev product, so not the Zaitsev product. That is, we don't get the more substituted alkene, we get the less substituted alkene. So it's going to give us an alkene. We're going to get a double bond following elimination of this nitrogen, but we will get the double bond, which would give us the least substituted product in the end. Now, in a more typical amine, it's a little easier to see how this works. So let's say we had the following, and we use the reagents. What that would mean is that we get this alkene in abundance, and then a little tiny bit of the Zaitsev product. And then this is the Zaitsev that we don't really get. So clearly we're losing this bond and we're getting a double bond there. That's what we're doing. Now it's a little harder to see that in our example, but in fact, what we're basically going to do is break either this bond or this bond. It won't really matter. And then we'll form our double bond here. And the reason for that is that we cannot really break this bond and form a double bond here because the phenyl ring prevents it, right? If we were to do that, and if I draw in the full phenyl ring, you'll see that it's not possible to create a double bond here because that would create a carbon with 5 bonds, right? So our only option is to create a double bond here and to lose one of these bonds. It doesn't really matter which. That's exactly what we'll do. So, excuse me. We can arbitrarily just say, let's lose that bond and install a double bond here. What will that look like? Redraw the part of the molecule that won't change. And then we'll say 1, 2, 3, 4, 5. This will be our double bond is, right? 1, 2, 3, 4, 5. Created the double bond right there. That's these 2 carbons here. And we broke the bond between this carbon and nitrogen.